talk about this is several the program control the instructions. We talk about MCR, and we talk about this is a JMP label, and we talk about this is subroutines, and we also so this is very important. We're programming the instructions. Today we talk about logic and math instructions. As I always tell you, so this is the PLC is just a specialized microcontroller, right? Supposedly, this guy is not just do something logic things, but this guy can do some logic and math instructions as well. We talk about logic and math instructions today. And so here are today's objectives, and we want to learn the basic comparison instructions, one A and B, and we'll compare and several this is the contents or this is the variables. I will learn the basic math instructions, math, multiplication, addition, subtraction, multiplication, and division, and maybe other. This is exponent. I can do this one also. And we learn the basic logic instructions. We learn the data move and the manipulation and instructions. So here are a lot of instructions we need to learn. Comparison instructions, and because you have already learned a lot of things engineering related. This is the subject. So you know the comparison. Comparison instructions are used to compare the contents of some addresses and with the content of some other address or with a constant value. So all of these instructions are used as input variable, right? All of these things are used as input variables, and if this is true, and they will turn on the runs output instructions. So these are the commonly used instructions. The equal means that if A equals B, then you just do something. So you just turn on set some variable height, set some signal height. Less, if A is less or equal to B, if this one holds, and you can do something. Not equal. If A is not equal to B, then you can do something. Great. If A is greater than B, you can do something. Less, if A is less than B, and you can do something. And GEQ, greater than or equal to. MEQ, and this one is easy to understand. So MEQ must compare for equal, and the limit, a limit test. And so, based on your experience, guys, for these comparison instructions, which one are totally new to you guys? Tell me. Mass compare for equal. This one, right? This one I told you I'm going to talk about this one. Okay, whenever we for all these things, as I said, because you are senior students now, and so you should be able to know all these things. But MEQ, what is MEQ? Limit test. The limit test is also new, right? So we are going to talk about these two new things, emphasize both of these two new things. For all other comparison instructions, we are very intuitive, and we know A is equal to B or A is less than B. So this is easy to understand. So comparison instructions. So here are the several examples. You can see these are 6 guys, and they are used as an input instruction, right? So if this condition is met, I'm going to do something else. So that means these 6 guys, these guys, they are input instructions. So you can see source A and source B, and source A you can either every instruction of these 6 guys, and they have 2 arguments. Source A, source B, source A, source B, source A, source B. We call this one, and this is the high level programming language. We call these as arguments. You guys agree? Okay, so but here are the convention. A source A must be a word address. And source A must be a address. Okay, that means and you are going to compare the content of this address with something else. But source B is the requirement is relaxed. So this guy can be a word address. If this guy is a word address, that means I'm going to compare the content of address A with the content of address B. But the source B can also just be a constant value. Alright? The source B can also be a constant value. So this is convention is valid for all these guys. Questions so far? So when you specify the first argument must be a word address. And you are going to compare the content of this word address with something else. So source B can be a word address or a program constant. If source B is a word address, that means you are going to compare the content of source A with the content of address B. And however, if this source B is a program constant, that means you are going to compare the content of address A with this constant B. And constant, that means value, and the integer or this decimal number and whatever number just is constant. Any questions regarding this slide? No question? Then this is a comparison. Okay? So this is MEQ. This is MEQ is special. As I said, whenever we see something totally new, and we need to pay more attention to it. Okay? And because so this is a totally new, that means this guy is not within our this is the knowledge, the limit. So we need to push the frontier of our knowledge. That means we need to know it very, very well. So it compares. So for this one, MEQ, okay, it compares the source location to the compare location or constant value after the source location has been filtered through a mask. So MEQ is special, and you can see. And so this guy has how many arguments? This guy has 3. Okay, so this guy has 3 arguments, and source A and compare B. You want to compare. We want to see if they compare this guy source, this argument, and this argument, and but we have a third argument, and the third argument means the mask that filters something. So whenever you see the mask, what comes into your mind, guys? During the pandemic, what is the reason we wear mask? Huh? I guess you forget pandemic. Pandemic is not over yet. So the mask means that we just filter something that we do not need, right? And when we wear a mask during the pandemic, and we want to filter some the screen some bad things, and make sure these bad things do not enter our nose and cause our a big trouble. Here is also, I will filter something. I do not want something come through. So the purpose is to allow program to compare only part of a address value with a constant or word address. Only part of value. I don't want to compare everything. Compare everything of this guy with everything of this guy. I only want to compare something of this. The mask passes data when mask bits are set 1. Right? So this is manipulation is conducted based on bits. I want you guys to write down. Based on bits. So usually these 3 guys, and they have the same length. That means they have the same number of bits. You know bits, right? Same number of bits. See, if the mask bits are set 1, okay? If the mask bit is set 1, and you can compare this guy's bit with this guy's bit, corresponding bit. However, if one bit of this mask is set to be 0, and then you do not need to compare the corresponding bit of source and the corresponding bit of compare. You understand, guys? Only when the corresponding bit of mask equals 1. So these two bits, one is from source, the second one is from the compare, and they will be compared. Otherwise, just a pause. So the mask must be the same element size, as I said, the same length. And here with 6 bits at the source and the compare address. Questions regarding this one? So it's very, very abstract. It's very, very difficult to understand, right? And then I'm going to give you one example. We will have an example later. Okay, so here is compare. I'm going to show you this. So this is my MEQ, and I will test your understanding of MEQ. Okay. So limit. So this is a limit. So it allows the programmer to compare input value with a high and low input limit value and give output if the input value is between the limit value. Okay, guys. If the test parameter is a constant, the limit values must be word address. So if the test parameter is a word address, then the limit value can be a word address or program constant. So limit, you have a lower limit and you have a higher limit. So this is the test, and you want to test this guy if this guy is within the limit range of these two guys. So this guy is special, okay? And we need to I'll give you an example to illustrate on how to use the limit. As I said, MEQ and limit, and they are pretty new instructions. You need to pay more attention to them. So here, the comparison. So all this means the light. So this is a shaded. Shaded area means this is light. So this light is the palette. So for first one, unequal, not equal, and source A and source B. Again, source A, the content of source A is 30. The source B is a program constant. 30 is not equal to 25. As a result, so this guy is true, right? Right, guys? 20 is not equal to 30. Do you guys agree? If this is true, so then, and so this the palette, so light, this light, palette light, PL means the palette light. The palette light is turned on, is energized. And as you can see, this is a bolt. You can see the bolt. This is a body. So this is the first one. And second one, greater than or equal to. And source A is a timer's ACC value. As I said, the timer's ACC value, you can visit it and you can retrieve the data from ACC. And you compare the ACC value of time 4 of timer 10 with respect to constant value 200. Right? If when this ACC value is greater than 200, and then you want to turn on this palette light. So this is what this diagram says. So this less than source A, and source A is also the counter C5, counter 10's ACC. And we want to compare the counter 10's ACC with the program constant 350. If the ACC is less than 350, until this palette light 1 will be turned on. And you should know this one, right? So because for the complex diagrams, and we will use them. So this is equal. Source A, source B. So both of these two guys, they are address. Address A, address B. For this first address, it is the timer zeros ACC and T4 timer C5 counter. Okay. You can have T41, that means first timer, T42 second timer, C51 is first counter, C52 is the second counter. You compare these two guys. If these two guys are equal to each other, so this palette will be turned on, palette light. So this is equal. So greater. So source greater than or equal to. If source A 100 here at this constant, it is greater than 23. Okay, that means this guy is true. As a result, this palette light is turned on, is energized. You can see the light, and then you can see the bolt. So this connection is folded. You understand, guys? So this is our basic comparison instructions, how they are used in our ladder diagram. And so you need to understand, then you can have better understanding of this diagram for our, we total have six complex diagrams. And then we talk about this limit and MEQ. We talk about MEQ first, okay? MEQ, and look at this one, MEQ. MEQ masked equal. I will have three values. The content of this guy, content of this guy, content of this guy. So suppose source, mask, and compare. And when you can see this, when you see these three guys, and what first impression comes into your mind? So these three guys, they must have the same length, right? They must, otherwise, you cannot compare. All right? So these are three guys, and you want to compare this guy and this guy bit by bit. Right now, guys, I want you guys to see, to know that. So this MEQ is comparing two guys bit by bit through a mask. All right? Bit by bit. Okay, now you can see, okay? So this is a mask. I have this mask. All these ones, all this is, I have 16 the bits. The lowest 4 bits are 0. It means what? It means that the lowest 4 bits of these two guys will not be compared. Okay? You can see the mask for the higher 12 the bits of the mask, and they are set 1. That means the corresponding bits of source and the corresponding bits of compare, and they will compare. You understand, guys? You can see, okay? For this special case, that means I don't care because these 4 bits are 0. Okay? That means I don't care these 4 lower bits. No matter what kind of this is the, I know this bits, no matter what kind of bits here, as long as these 12 bits and these 12 bits are equal bit by bit, then I can say this guy is true. You understand, guys? And I want one guy to come here to tell me his or her understanding of this MEQ. Last time Aiden came here, and also Ricky, right? Ricky came here also. And who want to be the next volunteer? Ready? Can you come here? Sure. Now ready. and it's going to show us on how this MEQ works in this for this special case.
So basically, you have a source value and a compare value that are taken from these addresses here. These are each of the bits for them, and basically, this is your mask code. So anywhere where there's a 1, it will compare this bit to this bit. But once you get to right here, these last 4 bits are zeros, which basically means we don't care about what the source or the comparison is here. It will basically ignore these, even if these were zeros in the compare, and these are 1s, which means they're not equal, because this is masked, we don't care that these parts are not equal. We're just checking the parts with 1s in the mask to see if they're equal.
Good. Thank you. Something ready. Any other questions, guys? So in the exam, I'm going to give you different values of these 3 guys. I'm going to tell me whether this guy is true or not. And then why? Use your own language to tell me why this guy is true, why this guy is not true. Yes? And before we move on to the next one, I'm going to repeat on what I just said. So the mask, first, so these 3 guys must have the same length, and the same length, and same number of bits. And then you just look at the mask. The mask, which piece of the mask is set 0? If this piece of mask is set 0, that means you will not compare the corresponding bit of source and here the compare. Okay? You only focus on the bits of the mask which are 1. And then compare the corresponding bits of the source and the corresponding bits of compare. You can see what is the beauty of this one. The beauty of this one is that I don't care the 4 lowest bits. What? I don't care. I just mask it, just filter it out. I only care the higher 12 bits. So this is MEQ. And then we come back and to the later to the limit. So the limit, you can see these are 2 axes here. So limit test, right? So limit test. So lower limit test, higher limit. If the lower limit, right? So higher limit, you can see it here, okay? Higher limit has a greater value than the lower limit. If this is the case, this is the intuitive case, the common case. Instruction is true for test value from 20 through 50. Instruction is false for test value less than 25 or greater than 50. So this one, okay? So if the lower limit is lower than a higher limit, if this is the case, within this range, true. Outside this range is false. Make sense? So second case scenario is that the lower limit has a greater value than the higher limit. Sometimes why we have this one, because when we retrieve the data from the content, we do not know which one is high, which one is low. All right? As I said, lower limit. So this guy is a home track. No, sorry. This is a address. When we run the simulation, this is the program. At some instant, we do not know which value is high and which value is low, because they are changing. Right? So if this is the case, that means if the lower limit has a higher one, if this is the case, within this range, false. Outside this range is true. So as I said, why we have this case scenario? Because when the program is running, so the content of this guy and the content of this guy, they are always changing. You have no control. That's the reason we have this. This is the case scenario to handle these things. Okay, that's okay. So here is the diagram. Here's one diagram. So we have the stop, first round, stop, start, and sew-in circuit. Now this time the sew-in is a solenoid. SOL means solenoid, right? We know that. Write down as if you solenoid, SOL means solenoid. We have learned the instructor actuator named solenoid. Solenoid means that if you energize it, and this guy can be pulled to a position or can be pushed to a position, and to help you for something. And so this is a solenoid. If the solenoid, okay, if I press the start button, the solenoid will be energized, and because it is sealed in there, and even though I momentarily release the start button, and the solenoid will be turned on and will be remain on, right? So this is start, stop, sew-in circuit. And second, when this solenoid A is energized, so this timer is triggered, and this timer on is triggered by this is the from force to true transition, and by this transition, and this guy will be triggered. Time base 1.5, preset value 15. That means the wall time will be 15 seconds. After 15 seconds, the damp bit will be set. The damp bit will be set here. The damp bit will be set. The solenoid B and will be turned on. So this is a power. This is the timer. For this is second round, we have the third round. Next round we have GEQ. We can see the GEQ. Okay, so greater than source is the timer one. Timer one's ACC value. If this is the source B is a 5, the program constant 5. If this ACC value is less than 5, okay, it's greater than 5, solenoid B will be turned on. Otherwise, solenoid B is off. And third one, next one, if the ACC value is greater than 10, another program constant, I'm going to energize the solenoid C. You can see, after 5 seconds, I energize solenoid B. After 10 seconds, I energize solenoid C. After 15 seconds, I energize the solenoid D. I can control these 4 solenoids one by one. And every of so these 4 guys will be turned on with the time interval is 5 seconds. Okay? First, I turn this on, and second, I turn this on, and third, I turn this on, and finally, when the timer is off, I turn on this solenoid D. Questions, guys? No question. No question. Let's move on to the next one. And also comparison. We have a button here. We have when we put the button here means that this is output, and so this is input, and all this is timer. It is the built-in timer of this PLC. If this guy is turned on, and then this timer is triggered, and time base 1.0 preset value 20. That means the wall time for this guy is 20 seconds. Right? After 20 seconds, and so this guy is going to do something. Then equal. If ACC equals 5, I'm going to latch is the palette light 1. Then if the ACC value equals 15, I'm going to unlatch it. That means for this is palette light 1 can only be turned on for 10 seconds. Okay. So this is a counter. This is a counter. If this one is turned on, the counter U, okay, counter U and the counter down, CTU and CTD, both of these 2 guys, they are triggered by force to true transition. Do you guys still remember? Okay, so if I press this one, so this CTU is triggered, a preset value is 50. Right? So that means out of the 50, so this is trigger the counter 1 will be reset. You need to know that, okay? For whenever you want to reset something, you must specify which you want to reset. You want to reset which timer or which counter. That means address. So here, less. If the counter's ACC is less than 20, I'm going to energize the pilot like 1. So this is what how this diagram works. Any questions so far? No questions? And then with logic, and this is a data movement instruction. Logic. And logic we know, and you can see all the 4 logic, 1, 2, 3, 4. All the 4 logic and the 2 data movement instructions, they are used as output. Right? Be careful. They are output. If some conditions are met, and they are going to do something. Only if the runs input logic conditions are true, will the instructions perform its corresponding function. So we have 6 instructions and logic A and B, and them together. This logic, okay, bit by bit. You have sense, guys? Write down. R, logic A and B, are them together, bit by bit. XOR. What is XOR, guys? You understand first.
Is it exclusive or?
Yeah. How it works?
It has to be either or, it can't be both.
Huh?
It has to be either or, it can't be both, right? It can't be.
XOR is a special, okay? If these two guys, these 2 bits, they are different, true. If they're same, wrong. No, same, false.
Yes.
Is how you understand, right?
Yeah.
Be very careful. XOR is exclusive, as this Drew says. This exclusive R. So how this guy works? We compare 2 persons, not 2 persons. I'm sorry, 2 bits. Okay. If these 2 bits are the same, false. Different, true. Not instruction. You just not A. If A is true, if you not A, that means false. If A is false, not A means it is true. Move data, MVM. So you can see there is another masked data move instruction. I'm going to talk about this one also. If I will, guys, I'm going to memorize MVM and also MEQ together. Okay, both of them are masked thing. So the value at and source A location is operated bit by bit. Keep in mind, bit by bit. I'm say and does not mean that A plus B and that means 1 plus 2 equals 3. No, that is bit by bit and the logic. At source B and the result is stored at the destination location. Source A, source B, and this is destination. And all these 3 guys, all these 4 guys they have. I'm sorry. For this not, because only one source. Not A. Okay, not A means A, if A is true, not A is false. Not A, if A is false, not A is true. Destination. So keep in mind bitwise and bitwise what's it? Bitwise R and bitwise, this is XOR. Then we talk about the move here, okay? Move. And the move, it allows the programmer and to move the contents of one source location to destination. And you move the content of this guy to the destination address. So both of these source and destination, they are addresses. You understand that? So MVM, and it performs the same function as the move instruction, except the data are moved through a mask before it is stored in the destination locations. And for this one, you need to look at the bits of the mask, and you should know that only when the bits of the mask equals 1, the corresponding bit from the source will be moved onto the destination. If the bits of the mask equals 0, the corresponding bit of source will not be moved from the source to the destination. Keep this in mind, okay? So this one, I will give you I'm going to show you, and then I will test your understanding in our exam. So here is the MVM. So if this guy is pressed, I'm going to move source to the destination via the mask. What does that mean, guys? Okay, I will give you an example here. The source, I have this kind of the content. The mask, if 0f, that means these 4 bits are 1, these 4 bits are 0, and these 8 bits are 1. Okay? Now I'm going to move. As I said, whenever you see this mask, and you must know what bits of this mask equals 1, what bits of this mask equals 0. If the bits of this mask equals 0, that means the corresponding 4 bits here, will not move from here to here. You understand? So only these 8 bits and these 4 bits for this source will be moved from here to here, and cover and overwrite this one. This is the original value. Questions so far? Questions so far? You can see this is the original value of my destination. And you can see what have been changed. So these are 4 bits, it does not change. Why? Because these 4 guys are equal to 0. That means 1, 0, 1, 2, and they will not be moved from here to here. As a result, so this guy remain intact, remains the same. Only though these 8 bits and these 8 bits from this source are moved from here and to here. As a result, these 8 bits and these 8 bits, they are different, and these 4 bits and see these 4 bits and these 4 bits, they are different because these 4 move here. So this 8 from here to here. You understand, guys? In the exam, I'm going to change the mask value. Ask you guys to tell me what is the final content of your destination address. For example, here is F0F, and I might use 5 and F00F. In this case, only the 4 bits, lowest bits, and 4 highest bits will be moved. Questions so far? Questions so far? Then talk about the math instruction. And we can do some math here. And so this is the logic is AND, and here is addition ADD. Be careful. All the math instructions are used as output element on a control run. Only if the run's input conditions are true, will the instruction perform its function. And we have addition subtraction, multiplication, division, DDV, NEG, and this is a clear instruction. TOD convert to BCD, and convert from BCD instruction and DCD decode. Decode instruction. So we talk about this one. Okay, so here is a we talk about the BCD. So what is the BCD? BCD means the binary coded decimal. Can you write down it? And BCD means the binary coded decimal. And for here, I'm just give you an example. So this column and these decimal values, and this is their corresponding binary value. So this is a BCD value, and so this is a hexadecimal value. All right. So what's the BCD, guys? BCD means that you just for example, I'm going to give you. So this is a decimal number 7863. For each of these numbers, okay. So you use its binary number to stand for it. For example, 3, this is 3 equals 0011 6 0110 8 1000 7 01111. So these are 4 totally. These are 16 bits. They are the BCD of this number. So you need to know how to do this correctly, right? How to do it correctly, guys? The key is that for each of these decimal number, you know how to convert it into a binary number. Make sense? So I'm going to give you a number in the exam and ask you guys to convert this decimal number into its corresponding the BCD number. Questions so far? Questions? As I said, this one will be tested. The key is that for any decimal number, and you should know how to convert it to its corresponding binary number. So math instructions, addition, subtraction, multiplication, DVV, DDV is double division source and decode. So they are used as output instructions. So clear TOD to BCD from BCD source is negate the source. And then this is example. I'm going to go through very quickly. So if this one is pressed, CTU is triggered, and the preset value is 350. If this is LS2 is triggered, CTU another counter is triggered 350. So then add these two guys together, source A, source B, and this is the ACC value of counter 1 and the ACC value of counter 2 together, and to put the sum of these two guys into this content. Then we compare this content of this guy with the 350. If this is greater than 350, and parallel 1 is energized. And if you press the reset, and you are going to reset both of these two counters. So multiplication, and you can press this button to multiply the 20 and with this is ACC value and put the multiplication, the product into this destination address. So if you press this A, and you can multiply by them and equal, if these two guys are equal, the palette will be turned on. So the math instruction, and so this one I'm going to omit, and you can just take a look at this one, okay? So math instruction, division, multiplication. So this is fill, copy and fill, and the copy source and destination length, and the fill is very, very similar. Okay, fill and copy is from source destination to the source address to the destination address, and fill source, and this is destination for length also here. So copy and fill, you can see source, this is my address. So this is my destination address. How long I want to copy 4 bits. I'm sorry, 4 bytes. So here it shows copy from here to here length and 6 units. So fill what? Fill this guy's number. Okay.